Hi everyone, this is question 10 now on paper 1 from 2024. It looks like we've got a nice finding in areas kind of question here. So it says figure 3 shows a sketch of part of the curve with the equation y is equal to 8x minus x to the power of 5 over 2, where x is greater than or equal to 0. The curve crosses the x-axis at the point A. Verify that the x-coordinate of A is 4. So something crosses the x-axis when y is 0. So what we need to do is sub in y as 0 into the equation for the curve and see what we get for x. So the first thing that I've done is I've factorized out an x from there, leaving me with 8 minus x to the power of 3 over 2. So that means that either x is 0 or 8 minus x to the 3 over 2 is 0. So we just add x to the 3 over 2 over the other side. Then we're going to reverse the powers. So instead of writing it as x to the 3 over 2, I'm going to put both sides to the power of 2 over 3. So that gets me back to my original x. So I get that x is equal to 8 to the power of 2 over 3, which means I cube root the 8 and then square it. So it's 2 squared, so x is 4 as required. So that's our, I know it's a lot of work for 1 mark, but that's the 1 mark. The line L1 is the tangent to the curve at A, so as shown there on the diagram. Use calculus to show that the equation of L1 is 12x add y equals 48. So we need two things in order to be able to find the equation of a line. The first thing we need is a point on the line, which we've got. We know that it is, we've got the point 4, 0. And we need a gradient. So in order to get our gradient, we're going to differentiate the equation of the curve, and we're going to sub in the point, the x-coordinate. So y is equal to 8x minus x to the 5 over 2. So when we differentiate that, we get 8, 5 over 2 times by x to the 3 over 2. Subbing in the point, which is 4, 0, we get 8 minus 5 over 2 times 4 to the power of 3 over 2. And when we work that out, that gives us a gradient of minus 12. So now we've got our gradient and we've got our point, so we can find the equation of the line using y minus y1 now. So y minus y1 gives us y minus 0 is equal to minus 12x minus 4, which is y is equal to minus 12x add 48, which we can write as 12x plus y equals 48 as required, because that's what we were aiming for in the first place. So that's the 3 marks done for part B. Now it says the line L2 has the equation y is equal to 8x. The region R, shown shaded in figure 3, is bound by the curve, the line L1 and the line L2. Use algebraic integration to find the exact area of R, 5 marks. So we're after finding this area here. Now I think we can do this in 2 steps. First of all, if we can find the area of this triangle, this big triangle here that I've indicated by shading it, this, and then from that, we're going to subtract the area underneath the curve, and what we'll be left with is the area R. So our first step is to find the area of this big triangle. Now, in order to do that, we need to know the coordinate of this point here, because that's going to give us our perpendicular height of our triangle. We already know the base is 4 because we know that the coordinate of this point is 4, 0. So yeah, we need to, so let's put L1 and L2 equal to each other. So the equation of L2 is 8x and L1 is that one. So we put them equal to each other and solve. So minus 12x plus 48 equals 8x. Add the 12x over there. So we get 48 is equal to 20x. Divide by the 20 and x is 2.4. We need to know the y coordinate because that's what our perpendicular height is. So let's use the easier of the 2 equations. So y is equal to 8x. So y is equal to 8 times by 2.4. So y is therefore equal to 19.2. So we've got everything we need now to find the equation of that triangle. So the area is equal to a half base times height. So a half times the base, which is 4, times the height, which is 19.2. So that gives us an area for that triangle of 38.4. Now, the next step is to find the area underneath the curve, which we're going to subtract. So we need to integrate the equation of the curve, which is our 8x minus x to the 5 over 2. So we're going to raise the power by 1, divide by the new power for the x. Raise the power by 1 goes to 7 over 2 and divide by the new power. And our limits are 0 and 4. So let's evaluate that now. 8 over 2 simplifies into 4, and 7x to the 7 over 2 divided by 7 over 2 is the same as timesing by 2 over 7. Then we're going to put in our limits of 4 and 0 to see what we get. So subbing in, we're going to get 4 times 4 squared minus 2 times by 4 to the 7 over 2 over 7 minus nothing. And that turns out to be an area of 192 over 7. So therefore, the last step, our area R, is the triangle, take away the area under the curve, and that gives us a fraction of 384 over 35. I'm going to leave it like that as well because of the way that the question says find the exact area for R. And that's a nice little integration, finding areas kind of question. I hope that you found quite a nice question, that one. I hope you found that helpful, and I'll see you in the next video.